All right, hello everybody. Welcome to the second part of the video for section 2.1, continuing on with our study of linear functions and looking now at starting to write some equations from information. Okay, so before we jump too far into that, just want to remind us how we calculate the rate of change for a linear function. So when we have 2 points, and if our variables are x and y, okay, so recall that the formula for the slope can be y2 minus y1 over x2 minus x1. But really, look at what we're doing here is a change in output over change in input. So remember that. So even if the variables you're working with are not x and y, this still works. So the difference in the outputs over the difference in the inputs. And as an example of that, let's say we have a function f and we have 2 points x1 and x2, and their outputs f of x1 and f of x2. Well, notice that this formula here looks very similar to the one we used in chapter 1 for finding average rate of change. So we can find our slope by doing f of x2 minus f of x1 over x2 minus x1. Okay? So when you use these formulas here now to find some equations of some lines, so we're going to start with the first one. So it says we have a line passing through the points -2, 3, and 4, 0. And we need to find the equations here for these, or for this. Okay? Well, the first thing we have to do if we're trying to find the equation of a line is find the slope. Okay? So we need to find our slope first. And here, because we're given 2 points, we don't know whether the variables are x and y, but we can kind of assume they are. So we can use the slope formula, the y2 minus y1 over x2, excuse me, x2 minus x1. And remember, where do the y's and x's come from? That's right, they come from the points. And just like with average rate of change, recall that it doesn't matter what I label as x2 and x1 here. What is important is if I choose this -2 here to be x2, then the 3 with it has to be y2. Okay, it cannot be y1. And that would make the 4 here x1 and the 0 y1, if I could write that correctly. Okay, if I had made the -2 there in x1, then the 3 would have had to be y1. Okay, so remember that things have to match up this way. All right, so we plug everything in the formula here. So we'll have y2, which is 3, minus y1, which is 0, over x2, which is -2, minus x1, which is 4. So we have 3 minus 0 on the top, which is 3. -2 minus 4, which is -6 on the bottom. So we end up with 3 over -6, which can reduce to -1/2. So our slope is -1/2. Are we done here, though? No, we have to still finish finding our equation. And so we have to go on to the next step, okay, which is going to be that we need to find the value for b, for our vertical intercept, right? Because recall our general form for a linear function is f of x equals mx plus b. We just found the value for m, that's our slope. So we still need to find the value for b here. And how are we going to do that? Right, we're going to use the slope here that we have together with one of our points. And it turns out it doesn't matter which point we use, we'll get the same value for b. I'm going to choose this 4, 0 since there's a 0 in there. And we'll plug that information into the general form there. So we'll plug in for f of x. Well, that's where our output goes. So in this case, from a point that's 0. M, the value that goes there is the slope, so the -1/2. The value for x, that's again from our point, that would be 4. And then we have plus b because we're trying to find the value for b. So this would give us 0 equals -1/2 times 4 is -2 plus b. And then we can add 2 to both sides. and find that the value for b is 2. So now we have the value for b. We can write our equation then. So we plug in, we know the value for m, we got the value for b. So our equation will look like f of x equals negative 1/2 x plus 2. Okay, and there we go. This is supposed to be a 2. All right. Cool. For the second one, I'm not going to go all the way through all the calculations. You can do those yourselves, but I do want to talk about finding the slope. Okay. And recall, as I said in the last slide, finding slope, the calculation is change in outputs over change in inputs. And from these pairs here, the f of 1 equals 5 and the f of 7 equals 13, we have to keep in mind what is the input and what is the output here. Well, recall the things inside the parentheses, those are the inputs, and the things over here by themselves, those are the outputs. So another way to think about this is we could take f of 1 equals 5 and f of 7 equals 13, and we could write some points. So this first one would become 1, 5. The second one would be 7, 13. And we would use those when we go now to set up our slope calculation. So we do the difference in the output, so I did 13 minus 5 over the difference in the input, 7 minus 1. Okay, so I just wanted to show that because sometimes there's confusion about how that works. All right, let's look at this example now. So we're told that in 2015, the total student enrollment at Pierce College was 20,230. When the college first opened in 1967, enrollment was 1,500 students. And fun fact, back in those days, the college was housed in an old Albertsons building. So this school was sometimes called Albertsons College. Assume the population of students at Pierce grew according to a linear model. So write an equation for the enrollment E at Pierce T years after 1967. Okay? So we need to write our equation here. Now, a few things we have to decide first. Well, even before that, the first thing we have to do, just like we did in the last one, is find the slope. Okay? Which, in order to find slope, as we saw, we need to have some points. Okay? And in order to have points, we have to find things that are paired up. We also decide what our inputs and outputs are. Now notice here they want us to write an equation for enrollment after T years, right? So that means that our ordered pairs and our points should have the enrollments and they should have the years. But we have to think about which one's going to go first. Which one will be the input, which one will be the output. So what will make the most sense? Would it make sense to input enrollments and output years? Would it make more sense to input years and output the enrollment? I think it makes more sense to do the years as the input. So say 2015. And then the enrollment as the output. So for example, we'd have 2015, 230. And then for the other one, we'd have 1967, 1,500. Okay, so those give us some points. However, before we find our slope, let's also notice one other thing. For the years here, right, it says that the values for T, for the years, are going to be years after 1967, right? So here in our points, rather than using the actual years, okay, whoops, sorry about that. So rather than using 2015 and 1967, we actually want to use the years after 1967 that each of those are. And I will tell you, this is a common practice when you're working with years. In writing some sort of equation, it's often easiest to do it years since something. Otherwise, you might get some crazy numbers. Okay? So 2015, how many years after 1967 is that? Well, according to my calculator, the answer there would be 48. Okay, and then 1967, how many years after 1967 is that? Well, it's the same year, so it's how many years after? Right, it would just be 0. Okay, so now we can find our slope. So we can do m equals, we'll do the difference in our outputs, and I'm going to call the 2230 my y2, which means 1500 is my y1, which means 48 is my x2, 0 is my x1. So my slope calculation will look like 20,230 minus 1500 divided by 48 minus 0, which if we subtract the tops there, we get 18,730 divided by subtracting 48 minus 0 gives us 48. And then dividing that gives us 390.208. Okay. So that will be our rate of change there. And first of all, I rounded that answer off to 3 decimal places because that's what I prefer as we go through things, that whenever we have decimal answers, we have many, many decimals, we use at least 3 decimal places, although it's often a good idea to use more. Let's also look at what the units are on this, right? So what were the units on these things up here on top? The 20,230 and the 1,500. Well, those were students. And then the 48 and the 0, well, those were years, right? So it looks like we have students over years, which means this 390.208 is 390.208 students, that's where it's supposed to be students, per year, right? Which, what is that telling us about this situation? Well, it's telling us that the enrollment was going up on average by 390.208 students per year, right? Which hopefully makes sense because it looks like from 1,500 to 20,230, we increased quite a bit. Okay, next thing we need to do, like we did in the last one, is find our vertical intercept, find our value for B, or our starting value, right? So I'm going to erase out some of this stuff. Okay, so now we need to find the value for B. And we could do like we did in the last one, choose a point, plug it in to that form, f of x equals mx plus b. So plug in a point with the slope, find b. However, in this case, I maintain that we already know what that value for b is. And what is it? Right, it's 1,500. Because recall that another value for, or another way to think about b, besides the vertical intercept, is the starting value, right? And that 0, or that 1,500, gives us our starting value for the enrollment of students. So that could be our value for b. Okay, so our equation then, we know the value for m is 390.208. We know the value for b is 1,500. Okay. And then we fill in our variables. However, pay attention that in the equation, or in the problem, right, they did not tell us to use x's and f of x's. Notice they told us to use E for enrollment and T for years. And recall that we said our inputs were going to be the times, or the years, so that'll be in the place of x. And our outputs were going to be the enrollments. Okay, so our equation will look like this. E equals 390.208t plus 1,500. Good times, right? Good times. All right, moving along. Let's talk about writing equations from graphs now. Okay. And first of all, in this picture here, it's a very bad example because they're not arrows on the end, so we'll add those. And when we go to write an equation of a line from a graph, we approach it the same way as we approached the last ones. Okay. First thing we need to do is find the slope. In order to find slope, what do we need? Right, we need points. And when we're getting this information from a graph, we want to try to choose points that are easy to read off of the graphs. So what I mean by that is ones that have nice, easy numbers to find. So like, for example, this one right here, looks like the graph points passes through a nice one there at -2, 2. And this one right here also looks like it's 4, 0. Okay. And then we can find our slope using those. So we'll do that y2 minus y1 over x2 minus x1. So m equals, I'm going to do 0 minus -2 over 4 minus -2. You got minus on both top and the bottom, which makes plus. 0 plus 2 gives me 2. 4 plus 2 gives me 6, which looks like it reduces to 1/3 is our slope. Okay? So we have m equals 1/3. All right. And then our next thing is we need to find b. And we know b is the vertical intercept. And in some cases with a graph, we can just look at the graph and find it. However, notice that when we look at that value there, it's kind of hard to tell exactly what it is. Like it might be -1.5. It might be a little less than that. Hard to tell, right? So we use our other technique here for finding b, which is we'll plug in the slope in one of our points into that f of x equals mx plus b form. And I'm going to use this point here, the 4, 0. So if I plug that in now, I have my output, which is 0, equals my slope, which is 1/3, times the x value, which is 4, plus b. 0 equals, to do 1/3 times 4. Recall, we can make the 4 a 4 over 1. When you multiply fractions, you multiply straight across. So 1 times 4 gives us 4. 3 times 1 gives us 3. So we have 4/3 plus b. Can subtract 4/3 on both sides. And when we do that, we would get b equals -4 over 3. That's supposed to be a 4 over 3. That's still not a 3. Okay? So now we know our value for m, we know our value for b, we can write our equation. So it'd be f of x equals 1/3 x minus 4/3. All right, and there we go. Okay, that's all for now. Thank you for watching.